circuit breaker versus retry, preventing cascading failures. Hello everyone! Today I'd like to walk through how to handle failures in distributed systems. When a service fails, the real danger is not the failure itself. It's how the system reacts to that failure. Because if handled incorrectly, a small issue can quickly turn into a system-wide outage. Core framework. When thinking about failure handling, I usually break it down into 4 aspects. First, retry versus circuit breaker strategies. Second, how cascading failures happen. Third, trade-offs like latency and load amplification. And finally, how real systems combine these approaches. Retry versus circuit breaker. Let's start with retry. Retry simply means reattempting a failed request. This works well for transient failures, such as network timeouts. It improves success rate with minimal complexity. But there's a major risk. Retries can amplify traffic. If a downstream service is already slow or overloaded, retries can make it worse. So the key idea is, retry helps recover failures but can amplify them. Now, let's look at circuit breakers. A circuit breaker monitors failures, and when a threshold is exceeded, it stops sending requests. It typically has 3 states: closed to normal, open to fail fast, half open to test recovery. This prevents sending traffic to an already unhealthy service, but it may reject requests that could have succeeded. So the key idea is, circuit breakers protect the system by failing fast. Cascading failures. Now let's talk about cascading failures. This happens when one service fails to upstream retries to load increases to more services fail. The key insight is, the biggest danger is not failure, it's failure amplification. Retries are often the root cause. Retry storms, thundering herd, exponential load growth. Circuit breakers solve this by stopping traffic, failing fast, allowing recovery. So the key idea is, good systems limit failure propagation. Trade-offs and design decisions. For retries, best practices include exponential backoff, jitter, retry limits, idempotent operations. For circuit breakers, we need to tune failure thresholds, open duration, recovery probes. There is also a key trade-off: retry to higher latency, better success rate. Circuit breaker to lower latency, but may drop requests. So the key idea is, we balance recovery versus protection. Real-world patterns. In real systems, we combine both approaches. Pattern 1, retry and circuit breaker. Limited retries first, then circuit breaker stops further damage. Pattern 2, retry budget. Limit total retry traffic to prevent overload. Pattern 3, fallback. When circuit breaker opens, serve. Cached data, degraded responses. Pattern 4, bulkhead isolation. Isolate resources per dependency to limit blast radius. So the key idea is, resilience comes from combining multiple strategies. Summary. To summarize, retry helps recover transient failures. Circuit breakers prevent cascading failures, but the real challenge is controlling failure amplification. Closing insight. To conclude, the biggest danger in distributed systems is not failure itself. It's amplifying failure through retries. Great systems fail fast, isolate failures, and recover gracefully. That's what resilience is about. Thank you.